Let's learn how to use the factor label method to complete metric conversions. First thing I want to say is this is probably one of the top 5 most important skills that you will learn in a chemistry class. We use factor label all the time. You may hear it referred to as dimensional analysis, or you may hear it referred to as fence post, and you'll see why when you see the method. But this is something you want to learn. I'm using the metric system to teach you the factor label method today because I get a lot of beginning chemistry students who just are not comfortable with the metric system. When I was a chemistry student in high school, I also hated the metric system, didn't want anything to do with it, honestly didn't think I needed it, and that's why I made a 0 on the very first chemistry test that I ever took. Luckily, I had a great teacher. He worked with me. I learned the metric system, and after that, my life was so much easier. So if you're a chemistry student out there and you're fighting that metric system, go ahead and learn it. It is super easy, and I'll actually do a real brief overview of that before we get started. So again, the metric system is super important. And in chemistry, these are the main ones in high school that we use, the main units, but there are so many more. This is definitely not an all-inclusive list. But we're just going to go over some of the basic ones that you're probably going to see today. But what I want you to keep in mind is no matter what prefixes in the metric system you're working with, if you can do this today, you can use any of them. It's just a difference in a number. So micro is very tiny. That means 1 million, and we write that as 1 times 10 to the 6th. You may be writing it as 1.0 times 10 to the 6th. I also want to point out today I'm probably just going to round 1 or 2 places past the decimal. This lesson is not concerned with significant figures, but especially if you're taking an AP or a college class, always make sure you follow your significant figure rules. Milli means 1,000. Centi means 100. Deci means 10. And kilo also means 1,000. Now, you may actually see this also stated as micro is 1/1,000,000th. Milli is 1/1,000th. Centi is 1/100th. Deci is 1/10th. That's actually the same thing. It just really depends on the context that you are viewing this from. So you'll see what I mean in just a second. What I want you to remember today is that these are all little. We're just keeping it real simple here. Guess we need a nail there. And this one is big. So we've got little units and we've got big units. And that's what we're going to think about it as. And then you're going to hear me talk about the base unit a lot today. The base unit is simply like gram, meter, liter. The base unit is actually the unit without a prefix in front. So these are your prefixes. This is your base unit. And one thing you can think about to help you think about these is a meter stick. So I'm going to use this as an example. Everybody knows about how long a meter stick is, obviously longer than this, but I'm trying to keep it in the screen. If you took a meter stick and you divided it into 1 million pieces, one of those little pieces would be a micrometer. If you took that same meter stick and you divided it into 1 million equal parts, each of those individual parts would be a millimeter. If you took that meter stick and divided it into 100 parts, each of those little parts, and you guys know what that looks like, would be about a centimeter. If you take that meter stick and you divide it into 10 pieces, each of the pieces is 1 decimeter. So these are all like fractions of the whole base unit. There's 1 million micrometers in a meter. There's 1 million micrograms in a gram. There's 1 million micro whatevers in a whatever. There's 100 centiliters in a liter. There's 100 centigrams in a gram. There's 100 centi whatevers in a whatever. If you just know the value and you understand these are smaller than the base unit, you know them all. Now, kilo is bigger. For kilo, it takes 1,000 base units to make 1 kilo base unit. So it takes 1,000 meters to make a kilometer. It takes 1,000 grams to make a kilogram. So these are big. I tell my students, if it follow on you, it will kilo you. Remember, it's really, really big. So that's probably the easiest way to think about it. Oh, also you could look at the meter stick here. If you lined up 1,000 meter sticks, you would have a kilometer. So if you're not comfortable with the metric system, make sure you at least review these prefixes and you know them. I promise you, it will make your life so much easier. Now, the cool thing about this is we can turn these around into ratios. And ratios are just relationships that compare. So, for example, I could write this ratio. There are 1,000 millimeters in a meter. Now, notice I'm not putting the 1 with that meter. It's understood. You could put the 1. It's not wrong, but in chemistry, I find it easier just to leave it like that. Let's give you another one. There are 100, we'll use grams this time, centigrams per gram. Does that make sense? Yes, because the centigram is smaller than a gram, so it makes sense there would be 100 of the little things in the big thing. There would be 1,000 of the little things in the big thing. Just a little tip for you, the way we're using these ratios today with the whole numbers, always link your number to the smaller of the 2 units. That is something I see students struggle with. When we start doing the problems, they're more concerned, does the number go on the top or bottom? Where the number goes is dictated by the unit. So always put the number with the smaller of the 2. For example, there's 1,000 meters in a kilometer. Now, let's use this as an example. This would not make sense. If I wrote 1,000 kilometers per meter, if you know that a kilometer is a lot bigger than a meter, this does not make sense. So this would be a no. However, you can flip the value. You've just got to keep the number with the right unit. I could write a kilometer is 1,000 meters. That's okay. I could write a gram is 100 centigrams. That's true. That's okay. I could write a meter is 1,000 millimeters. Also okay. So what I want you to know about the ratios is this. You can flip them. You're going to need to flip them. That's going to be a really important skill. But when you flip them, always make sure they make sense. Make sure you have your number with the right unit. And again, the rule of thumb there is put the number with the smaller of the 2 units, and that is an easy way for chemistry students to remember. So that said, we're going to jump in and I'm going to show you how to do some examples. So just think about this as someone sitting down right beside of you and just working these out. So number 1 says convert 0.75 meters to millimeters. So my given is 0.75 meters. So I'm going to write out a plan here. They gave me meters and they want millimeters. I know a millimeter is smaller. I also know that means 1,000, so just some little things to have in mind. Now, when we do factor label, the first thing you will always do is write down the given. Even if you are like, I don't even know where to start, you can always write down the given. So we're going to write down 0.75 meters. Now you're going to draw a long line and a short line. Now you ask yourself, do I know a relationship between meters and millimeters? Do I have a direct ratio? And the answer is yes. You know there are 1,000 millimeters in a meter because that millimeter is small, and you know milli means 1,000. Now when we do the factor label process, and that's what this long line, short line is that I'm teaching you, here's how you play the game, and that's how I want you to think about it. Whatever unit is on top always has to be on the bottom in the next step or the next little slot. So because meter is here, I automatically know meter's going to have to be here. By default, if meter's on the bottom, your millimeter will have to be on top. And you can also think about it as I'm going from here to here, from bottom to top. I'm going from meter to millimeter. Lots of ways to look at it. Now, I know the 1,000 is going to have to go with millimeters because out of these two units, this one's smallest, and that relationship makes sense. Meters cancel, which is why you always want the unit on top, on the bottom in the next step. Once you have the unit that they're asking you for on top, you're done. So at this point, we're going to write equals. And here's how you calculate a factor label problem. Super easy. You're going to multiply everything on the top together. And in this case, if you punch in 0.75 times 1,000, you're going to get 750. Now, I'm breaking this down just a little bit more than most of you are probably going to need to do, but I just want to show you how this works. So you've multiplied everything on the top together, you write it down. You multiply everything on the bottom together. These are just understood ones. You would write it down. You won't always have just ones on the bottom. That's why I'm showing you this. Then you divide the top by the bottom. So your answer is 750 millimeters. Now you might be saying, that's a lot of work for something I could have done in my head very easily. Or I could have just moved the decimal. With the metric system, most students can. But what I want you to remember here is I am teaching you this method of problem solving, and I just happen to be using the metric system to do it because most people are already familiar with the metric system. This method is what's super important because very soon we're going to be doing gram, mole, atom, molecule conversions. We're going to be doing limiting reactants, stoichiometry, and all of those require this skill. And if you learn the skill now with something easy, when we get to the more difficult material, it's not going to be hard for you. So we're learning the process today. All right, let's do number 2. How many centiliters are in 4.53 liters? I like to circle my given so I know where I'm starting. They gave me liters, they want centiliters. I know centi means 100. I also know a centiliter is smaller than a liter, and I know there's 100 centiliters in a liter. That's just good to know in case I need it in just a moment. So we're going to write down the given first. I have 4.53 liters. Draw your long line and your short line. Now you can see why some people call this the fence post method. Now, because liter is here, I know it's going to have to be here, so I'm just going to go ahead and jot that down. I may or may not put a number with it. Do I know a direct relationship between liter and centiliter? Yes, I do. I know there are 100 centiliters in a liter. Since liter's already on the bottom, I know that that automatically puts the 100 centiliters on top. Now, does that relationship make sense? Yes. Centi means 100. Centiliter is smaller than liter. That looks correct. Liters cancel. Those are out of my hair. They did ask me for centiliters. Hands off, I'm done. We're ready to calculate. Multiply everything on the top together. In this case, 4.53 times 100 is 453. Multiply everything on the bottom together. 1 times 1 is just 1. Again, that's a little overkill, but I just want you to see sometimes you may have something on the bottom. 453 divided by 1 is 453. Your unit is centiliter. Box your answer. This is the only step right here where we're not worried about units because I'm considering this scratch work. But I do want to point out, you have to put units in every single step. That's how you keep up with your work. That is a good thing. You want to put your units there. Otherwise, you're going to get lost in the problem. And these are easy problems. When we get to more difficult problems, that's going to help you keep up with your work. It also helps your teacher maybe give you partial credit on things because they can follow what you're doing. Always put the units with your final answer. And again, I just rounded to whole numbers here. If you're in a more advanced chemistry class, make sure you're following your instructor's rules for significant figures. Now, let's look at the next one. We've got 6.3 times 10 to the 8th micrograms. That is my given, and we want to know how many grams is that. So I am going from microgram, that's your symbol for micro, to gram. I know micro means a million, and I know there's a million micrograms in a gram, so that's helpful information for me. So let's write down the given. 6.3 times 10 to the 8th micrograms. Long line, short line. I know that microgram has to go on the bottom, and I know that I'm going from microgram to gram, going from bottom to top. I know that micro is definitely smaller, and there's 1 times 10 to the 6th micrograms per gram. Micrograms cancel, leaving you with grams on top. So we're good to go. Now we're ready to multiply across. 6.3 times 10 to the 8th times 1 is just going to be 6.3 times 10 to the 8th. 1 times a million's a million. So we multiplied across, we wrote it down. We multiplied across, we wrote it down. Now, some of you are looking at this and saying, that is ridiculous. I can put all that in my calculator, and you probably can. I am preaching to the crowd that may not be as confident in their math skills. So they may need to multiply across and write it down, multiply across and write it down until they are confident they're putting things in the calculator correctly. So now we're going to divide these two numbers, and just a word of advice here. Remember that when you put this times 10 into your calculator, you're not actually touching the times or the 10. Don't do that. You're using this exponent button on my calculator. It's right here. It's the second function, EE. Yours might say EXP. I have trained myself to say times 10 when I use my calculator because I know I don't want to touch times 10, but I know this is going to do that for me. So times 10. If you just have one button to hit, when you touch it, say to yourself times 10. That will get you in the habit. So 6.3 times 10 to the 8th. And you can see what that looks like. That little E that you see means times 10. Divided by 1 times 10 to the 6th. And that equals 4.5. Actually, I punched the wrong thing in. Sorry about that. I was looking at the next one. That equals 630 grams. I was right. 630 grams. So the tip there is make sure you don't touch times or 10. You're hitting either your EE or EXP button. Now, some calculators that are a little nicer, this is just the basic Texas Instruments scientific calculator. I love it because it's simple. But if you've got like maybe a graphing calculator or something else, you may actually have a button on yours that says times 10 to the X. That's your exponent button. Don't get that confused with 10 to the X. That is not the same thing. So just play around with it until you're getting the right answer and you know that you're using the right functions on your calculator. All right, next. I've got 4.5 times 10 to the negative third. You want to be careful with that, kilograms. And they want to know how many grams that is. So I'm going from kilogram to gram. And we'll go a little faster through this one because this is our fourth example. Write down the given first. 4.5 times 10 to the negative third kilograms. Long line, short line. Kilogram is here, so I know it's going to have to go on the bottom. I do have a direct relationship between kilogram and gram. I know there are 1,000 grams in a kilogram because a gram is smaller. So I'm going from kilogram to gram. I know that I'm going to put the 1,000 here because that makes sense, 1,000 grams per kilogram. Kilograms will cancel. I'm going to multiply straight across, and I'm going to get 4.5 grams. You know, this is just a 1 on the bottom, so if you divide that by a 1, you're just going to get the same thing, 4.5. So those problems are what I like to call straight shot. You know the relationship, and all you got to do is multiply the given by that ratio. But sometimes we get problems where we do not have a direct relationship, and that's what we're going to look at next. Sometimes we don't have a direct connection, and in that case, we're going to have to go home. Real quick little story. Let's say that I finally get to retire from teaching like 100 years from now, and I buy myself a little island, build a hut on it, and this is where I'm hanging out. I'm enjoying my new little island. I probably had to win the lottery to do that, but there's my little island. I know the route to the Walmart, which is just a few islands away. Got to be able to get to the grocery store. Okay, so there's the little island grocery store. And I also decide I'm going to get just a little part-time job on this little island. I'm working at the little island cupcake factory. So I can get back and forth between my home and work all day long. I can get back and forth between my home and the grocery store all day long. One day I'm at work though, and I really need to get to the grocery store. Like it's crucial. I have got to get to the grocery store. Something I got to have, but I don't know that route. There's no GPS, there's no phone. It's just me and my boat. How am I going to get from here to here? I have no idea. If I'm really desperate, what I could do is go home, and then I could go from home to the store because I know both of those routes. You can always go home. Was it a little out of my way? Yep, but did I get where I was going, where I needed to go? Yes. That's what we're going to be doing on these problems. Sometimes we don't have a direct path, and we're going to have to go home first. And home is your base unit. And by base unit, I'm talking about gram, meter, liter. That unit without a prefix in front. So let's look at this first example. How many millimeters are in 3.6 kilometers? First thing that stands out to me is both of these have a prefix in the front. That tells me I don't have a straight shot. Now, there's probably somebody out there who knows how many millimeters are in a kilometer. Off the top of my head, I don't know, and I don't care. I don't want to know all the ratios out there. It's just too much. I just need to know the basic ones. So I'm going to have to go home, which in this case is going to be the meter, and then I can get to my goal. So here's my plan. They gave me kilometers, so I'm going to go from kilometer to meter, which is the base unit, and then I'm going to hop over to millimeter. Is it a little more work? Yes, but it's easy. So let's write down the given first. I've got 3.6 kilometers. Now my long line this time is going to be a little bit longer because I'm going to have an extra little slot in there. So I've started with kilometers. Where can I go? Well, I know kilometers are going to have to be on the bottom, and I know that I can always go from a kilometer home. And home is just cover up the prefix, and there's your home. I can go from kilometer to meter. Now I knew kilometer had to be on the bottom because it was on the top here. I know meter's smaller, and I know that there's 1,000 meters in a kilometer. Done with kilometers, out of our hair. Now because you have meter, I'm at home now, but I still got to get to millimeters. I'm going to put meter on the bottom because it's on the top here, and I'm going to millimeters. Do I know how many millimeters are in a meter? I do. There are 1,000. The 1,000 goes with millimeters because millimeters are smaller than a meter. Meters cancel. I'm ready to calculate. All I'm going to have to do in this case is multiply everything on the top together because the bottom is just going to be a 1. if I multiply all of that together, I'm going to get 3,600,000. Millimeters. Now, in science, we don't like writing all those zeros. So what I'm going to do is put that in scientific notation. Quick review. Understood decimals here. You're counting decimal places. 1, 2, 3, 4, 5, 6. 3.6 times 10 to the 6th millimeters. Those numbers are both the same thing. I always prefer my students write a number like that in scientific notation. Now, if I would have said go 2 places past the decimal, it would have been 3.60 times 10 to the 6th. But remember, that exponent indicates the number of decimal places you move, not the number of zeros. Sometimes students get that confused. All right, let's look at the next one. I have 3.5 times 10 to the 7th micrograms. How many centigrams is that? I notice right off the bat, I've got 2 prefixes. So my plan is to go from micrograms home to grams and then on to centigrams. Remember, when you take the prefix off, that tells you where home is. So I'm going to write down the given first. 3.5 times 10 to the 7th micrograms. Long line, short line. I know micrograms is going to be on the bottom, and I know I'm going home to grams on the top. Micrograms smaller, I know that there's 1,000,000 micrograms per gram. We're done with micrograms. Now, not there yet because I still got to get to centigrams. I know grams going to go on the bottom because it was on the top here. I know that there are 100 centigrams in a gram. Just look at it. Does that make sense? Yes, a centigram is smaller and centi means 100. I'm done. I'm going to multiply across the top. Now, if I multiply across the top, I'm going to get, see, 3.5 times 10 to the 7th, and that's what that looks like in my calculator, if you can see that, times 100. Now, if I write that down, that's a big, big number. I've already hit equals. Make sure you hit equals and then divide by that one number on the bottom. This is for people who aren't writing down the top and bottom. You can do it either way. And I'm going to get 3,500 or 3,500 centigrams. I can put that in scientific notation by moving that decimal, so I could also write it as 3.5 times 10 to the 3rd centigrams. It's very important, students, that you pay attention to what your teachers are asking you to do here. It's also real important that you know those are the same thing. So that's something you may want to review if it gives you some trouble. All right, we're going to do one more of these, and I would encourage you, I hope you've been doing this, but maybe write that down, try it yourself, pause, see if you can get it, and then check out my answer. So this time I'm going from 12.5 kiloliters to milliliters. Going home, home is going to be the liter. I know kiloliter goes on the bottom, leaving liter on the top. I know a liter's smaller because kilo's really big, so there's 1,000 liters in a kiloliter. Kiloliters are gone. I know liter's going to be on the bottom. Why? Because it was on the top in the step right before. I am going to milliliters, and I know there are 1,000 milliliters in a liter. It's almost like you have little puzzle pieces, and you're figuring out how am I going to turn it to lock it in each time so that I cancel on the diagonal. Remember, that's the name of the game. That's going to be a 1 on the bottom. So we're just going to multiply these numbers on top, right across, and you're going to get 1.27 times 10 to the 7th milliliters. Now, you may have your calculator already set up to give you that answer in scientific notation. It may have given you standard notation, and you had a whole bunch of zeros, and you've converted it to scientific notation. But just actually make sure you are touching the buttons on your calculator, checking behind yourself to make sure you're doing it correctly. So, in summary, here are the things that you need to remember about the factor label method. Number one, we always write down the given first and draw a long line and a short line. Even if you don't know what's going on, you can do that. For example, with this problem, I know I can at least write down 2,500 milliliters, and I can draw a long line and a short line. Everybody can start there. Next, make a plan. Ask yourself, is it a straight shot, or am I going to need to go home first? For example, in this problem, you've got 4.5 meters and they want micrometers. I know a direct relationship, so I'm going to be able to go straight from meters to micrometers in this problem. But in this problem, they're asking me to go from kilometers to micrometers. So in this case, I'm going to have to go from kilometer to meter to micrometer. In this problem, I have to go home, and my clue is the fact that I had a prefix in front of each of these values. And just remember, home is the base unit without a prefix. Gram, meter, liter, second, whatever. It just means you don't have a prefix in the front. Couple other things to remember when you're doing these problems, and this is really good stuff to write down if you're new at this. The name of the game is canceling on the diagonal. If I start off with liters here, liters is going to have to be here. If I have milliliters here, milliliters is going to have to be here. And you could just keep going and going and going. So whatever's here has to be here on the next step. You know you're done when whatever unit on top is what the problem is asking for. Make sure your ratios make sense. That's something real quick and easy to do. If you're doing a problem and you write down 1,000 liters per milliliter, step back and look at that. That does not look right because a milliliter is really tiny. So you know that should probably say there's 1,000 milliliters in a liter. That makes sense. That does not. Remember, put the number with the smaller of the two units. For you beginners, that's going to make your life a little easier. Also remember, once you've got the problem set up, you might have 2 slots, you may have 10 slots, depending on what you're doing. But you're going to multiply the top together. You're going to multiply the bottom. This is just making it real simple. And then you're going to divide. Those of you, again, that are real savvy with your calculators and you're great at parentheses and all that stuff, you know, you just go on with your bad self. But if you're weak at math skills, do it this way, and it might not hurt you to do it this way just to make sure you've got it in the beginning. I see a lot of mistakes with real smart students with calculators because in their head they know what they're doing, but sometimes the calculator is not understanding what you're trying to tell it. And last thing, put units in all the steps. I cannot stress that enough. When you write something like this for my students, if I get something that looks like this, and then they've got an answer, I don't give that credit. I have no idea what they're doing. If you don't have units here, you're not sure what you're doing. So always put units in every single step and always make sure that you box that answer. And honestly, guys, if you've got a teacher and they're just constantly on you about show your units, I didn't give you credit because you didn't show your units, that's not for them. They're just not trying to like take you down because you didn't show some units. Showing units is good technique. It's proper technique and it's correct technique, and it will make your life easier, and you'll be able to double check your work and you'll be more successful in chemistry. So I hope this was helpful. You're gonna see this skill, factor label, dimensional analysis, show up all throughout the course. Practice it here, get confident in your skills here. You're gonna get the metric system review as a bonus, and then you're gonna be able to do much bigger more complicated problems, and you're going to be able to do them correctly.